Here's an example of a quadratic regression problem. So we are given a table here. Here's a table of some tuition for a semester at CBU in dollars for years since 1990. All right, so got to keep that in mind. That's useful. All right, so these are years since 1990. So this would represent 1993, 1995, so on and so forth. So we're given a plot here. We got several parts to this problem. And so on this plot, it's graphed out the points. And we have a curve here. And we have a straight line. And so these are two models. The line is what we call a model. And the question is, which one better fits the point? Does this line fits the points? Or does this curve fit the points? Well, notice this line. As this line comes through, it doesn't touch the point here. It almost hits that point. It hits this point good, misses this one, misses this one, misses that one, miss, hits that one right there, kind of hits that one and misses. So the line is not a good fit. The curve, though, goes pretty much through all those points. So the first question is, using that scatter plot, which one seems to fit better? Well, a quadratic definitely fits better. That curve is a quadratic. How do you know it's a quadratic? Well, we know it's not a line, and those are our only options here. All right, the curve goes through it pretty good, touches all the points. It's not perfectly in the middle of all the points, but it's a pretty close fit. Now, we're going to let C of t be the cost of tuition. That's our function there, and that's the cost of the tuition in t years since 1990, and we want to get a model, a quadratic model. Okay, a model is just an equation. That's what we're looking for. We're looking for an equation of this curve. So this is C of t there. All right, what is that equation that makes that graph? Well, we got to do some regression. So here's the basic steps. We're going to get out our calculator here. All right, so we got our TI-84 here. And let me scooch that over just a little bit. That's good. Okay. So anyways, what we're going to do here is we're going to graph this. We're going to go to Stat. And there it is, Stat. And then we go to Edit. And we're going to get our list. Now, I've already entered our list for sake of time here. And so we're going to enter all those into List 1 and List 2, the years and the tuition. All right. Now, if we want to see a graph of this, we can go to our graph. And actually, I got an equation in there, so I'm going to go to my y equals. And I'm going to clear out this equation. I don't want that there. So let's go to the graph again. There's nothing to see. So if we go to Zoom, and we go down to Zoom Stat, which is number 9 right there. Hit Enter. And, oh, I haven't turned the plot on. Let's go turn the plot on. That's right. So before we do that, we've got to turn the plot on. So I'm going to go over up here, and I'm going to go down to on, which, okay, enter. There you go. Now it's on. Okay, we're going to go down, color blue. Okay, so we got the type. We want this scatter plot. We want to make sure it's list 1 and list 2. Now if we go to Zoom and Zoom Stat, which is number 9, there they are. So you got to turn your plot on and get that graph. Now, you don't necessarily have to look at that, but if you want to, it's nice. You can kind of see it fits this graph that we have on the page. All right, so there's the graph of the points. It also will kind of let you know if you have some points that you accidentally entered wrong. If there's one of those points that's totally out of whack, you may have entered something wrong. All right, so we need an equation here, okay? So let's go find our equation. We're going to go to Stat. I'm going to go over to Calculate. And we're going to go down to a quadratic regression, quad reg. We'll hit Enter. Now, different calculators, depending on the how old the calculator is there. All right, will look a little differently. Okay, if some calculators may not even have this list, and if you used L1 and L2, then you can just hit Enter and you're good to go. Okay. Now, one nice option is a store regression equation. This is totally optional, but if you want to do this, you can go to vars, you can go to function, and go to y1. Again, that's vars function y1, all right? And what that'll do is that's going to put this equation in that y equals menu. So let's go ahead and enter that. All right, so there it is. So this is our regression equation. So this is the equation that best fits it. So it's a quadratic equation. We have 8, let's see, what is it? They want us to write it down to 3 decimal places. So use 3 decimal places, all right? So we got to write it down carefully. So 8.736 x squared. The b value is 254.780x. I think I'm kind of out of room. Nope, got room there. And then plus 3567.901. All right, so there's the equation that best fits that. All right, so now what we need to do is we need to find out, we need to estimate the tuition at 2013. Well, 2013, remember this is years after, what did it say? Years after 1990. There it is, it highlighted. Years after 1990. All right, so how many years after 1990 is this? Well, this is 23 years, so T is 23. So 2013 minus 1990 is 23. Okay. Now we can do this a couple ways. One, we can type this back in. So this is 8.736 times the time squared plus 254.780 times the time, or times the x value. I suppose I should have put t in here, all right? So let me do that real quickly, all right? So our independent variable is t. X is the same as x, but there we go. Plus 3567.901. So there it is, all right? And so that is 14,049.185, which actually rounds to 16 since this is, or 19 since this is dollars. We should round it to 2 there. All right. So there's our expected tuition. All right. Now, let's see. The second way to do that is this. Now, since I put the y1 in there, I told it when I did the regression to enter the equation to y1. There it is in the equation with all those decimals entered. So another thing I could do, since I have that entered there, I can go to vars function y1, and in parentheses I can type 23. This is y1 of 23. So this is going to put 23 into the x value and tell me what the y value is. And there it is. All right. Now that's actually a little more accurate. And the reason is because of all those decimals of accuracy. I rounded off some. So notice the cents are a little differently. All right. Hopefully on my open math there, it would allow either one. If it didn't, I would say ask your teacher there to give you credit, because it should work either way. All right. Last but not least, we want to know what happens, or what year will give us a tuition of 15,575. Okay, so that means we need to find a t value that has 15,575 is equal to this whole thing, 8.736 t squared plus 254.780t plus 3567.901. All right. Now, that's a pretty big, ugly equation to solve there. We could use subtract and use a quadratic formula, but that would be pretty ugly. So we want to use a graph approach here. All right. Here's our function right there. And if we hit graph, you'll notice there it is right there. So the best way to do this is to use our graphical approach. And that is by going to our second equation and do 15, 5, 7, 5 and graph. And you'll notice it doesn't show there. I need to change the window. Okay, look at my graph again. Look at the y value. The y value only goes up to about 12,000. I need to be up to 15,000 here, actually 16,000. So if I go to the window, this changes what we're looking at, and we want to change our y max. Where's my y max? Oh, there it is. Y max. Let's change that to 16,000. I want it to go all the way up to that so I can see it. There it is. Now notice the red line and the blue line don't cross, so I'm going to need to go out farther on my x. And so let's go on out to 25 years. Let's see if that works. Ooh, close. Need to go farther out. I'm going to go to window. Let's make this go to 30 years. I want to see where they cross. There you go. We can see where they cross. If I hit trace, I can kind of get close. If I trace, you see those, they're getting close. They cross. You can see down at the bottom here at about 25.2 years. We can find out exactly where they cross by going to second, calculate. Let's go down to intersect. And it wants a left bound. All right. And let's see there. Okay. So I'm just going to go enter there. And it wants something to the right of the intersection point. So I'm going to go way beyond, hit enter. And it should find it. The intersection, there it is. Okay, in the middle there, the intersection is at the point 25.256 years. And the cost is 15,575. That's what we were going for. All right, so 25.26 years. So the question says, use the model to predict which year. So this is in 25 years. So we need to add that to 1990 plus 25.25. Well, that's going to be the year 2015.25. All right, so in the year 2015, the tuition will hit that price. All right. So that's the idea. So we enter the numbers. We do a quadratic regression to get this equation here. Let's go ahead and make this larger. There we go. We use the regression to get this equation. Then we're going to plug in 23 to get this. This is C of 23. And then we're going to want to use a numerical method, use a graphing method to solve this, because that's just plain ugly to get by hand. Even though you could use negative b over 2a and find the vertex. First you need to subtract this to set equal to 0 and go from there. But this is your best approach to use a graph because it's an application problem. All right, hope that helps. Thanks a lot.